Solving equations by using additive and multiplicative inverses. Okay, so firstly, we need to know what additive inverses and multiplicative inverses are. Okay, they are horrible words. So your additive inverse is what you add to something to make 0. So a plus minus a equal to 0. That's like the theoretical part of it. So for example, 5's multiplicative inverse would be negative 5. Negative a half's multiplicative inverse would be plus a half. So whatever you add to something to get 0, opposite sign basically. Multiplicative inverse would be like a times 1 over a is equal to 1. So whatever you multiply with a number to get 1 as an answer. So, in other words, 5's multiplicative inverse would be 1 over 5, or divide by 5. Okay. 2 over 3's multiplicative inverse would be 3 over 2, the reciprocal of it. So whatever you multiply with something to get 1 as an answer. And those are the basis of what, or the basis on which we solve equations. Okay. So oftentimes it's easy, you can just see the answer, and that's also fine. But the more complex the equations get, the more you rely on these bases. So if we look at the first example, here we have x minus 3 equal to 7. So we look at what is happening to x. In this case, we are subtracting a number from x. So we have to do the inverse. We are going to add 3 on both sides. So you don't have to write it this way. You can just say x is equal to 7 plus 3, and therefore x is 10. Okay. So when we subtract, we want x on its own. We're looking for x. We add 3 if we were subtracting 3. In the next example, there we are plusing 5. So we are going to subtract 5 on both sides of the equation to keep your equation in equilibrium, which is a very fancy word for balance. So we want to say 7 minus 5, which is 2. Then in C, you'll see there's 2x. So the important thing we need to know is 2x means 2 times x is 14. So you're looking for what number times 2 is 14. If you just know it's 7, that's fine. Otherwise, we look at, okay, here we have a times 2. We want the times 2 to go to the other side, so we're going to divide by 2. Leaving us with x is equal to 7, because those 2's cancel, they make 1x. Okay, then in our last example, we have x divided by 3 is equal to 4. So we're going to go and do the inverse of divide by 3, which is times by 3. So we times by 3 on both sides. Therefore, x is equal to 4 times 3, which is 12. Okay, so it is really up to you whether you want to add the what I did every time here in color. It's not strictly necessary, but I do think it helps a lot of people see what you are doing. Okay, so every time we are working with the inverse operation. That's what the multiplicative and additive inverse story is about. Okay, now we're going to look at some more complex examples. So in each of these examples, you'll see there's something more going on. So in each of these examples, you'll see there's something more going on. In this example, if we go look at what's happening to x on our left-hand side, you'll see in orders of operations order, we are timesing 2 and we are adding 4. So now we are going to have to work backwards. First, we get rid of our plus 4 by minusing 4, and then we get rid of our times 2 by dividing by 2. So let's first get rid of our plus 4. We're going to subtract 4 on both sides of the equation. So that we have 2x is equal to 12 minus 4, which is 8. So 2x is 8. Now we've done our first part. We've gotten rid of that plus 4. Now we have to get rid of our times 2. And we get rid of a times 2 by dividing by 2 on each side of the equation. Therefore, we have x is 4. Next example. Again, on our left-hand side of the equation, if we look at what's happening to x, we have a times by 3, and then we have a subtract 5. So we're going to work in the inverse direction. First, we have to get rid of this minus 5 by doing the inverse operation, which is plus 5. So we will have 3x, this makes 0, is equal to 17 plus 5. So we have 3x is 22. So we have 3x is equal to 22. So now we've dealt with our minus 5 by adding 5. Now we have to deal with our times 3 by dividing by 3. So now our answer for x, because 3 divided by 3 is 1x. Our answer for x is going to be 22 over 3. So you're welcome to write this as a mixed number if you really want to. It's not necessary though. It is more important that you have a simplified fraction. And then our last example we're going to do now. On our right-hand side, you'll see this time x is on our right-hand side. We have a times 4 and we have plus 7. Okay, please note every time I'm writing this in the orders of operation of what we will do first from BEDMAS. So first we multiply and divide, then we add and subtract. So now we work backwards. Yep, so first we're going to deal with add or subtract. So we're going to deal with this plus 7 by subtracting 7. Okay, 7 divided by 7 on that side is equal to 4x. So we'll get 4x is equal to 0. Okay, now you can straight away just write down the answer if you feel like it. Or you can say, okay, I'm going to divide by 4 on each side of the equation. Therefore, my answer for x is going to be 0.